Hello grade 9s, this is video 3 lesson 1. In your previous video, so that was the videos for lesson 2, we had a look at charge. We said that charge was an amount of electrons. Charge was actually 6,25 times 10 to the 18 electrons, and we said that current is the rate of flow of charge, how quickly charge moves around a circuit. Today we're going to look at potential difference. So we're working from page 10 of the notes. Electrons will only move around a circuit if there's a difference in electrical energy between 2 points in a circuit. A difference in electrical energy between 2 points so that they can be repelled by one point and attracted to another point. Another term for this is potential difference. Or informally, we can also call it voltage. The correct term is to use potential difference. Saying voltage is like going, yeah, no, cool, how's it, bro? You don't talk like that in science. You need to be formal, so we use the word potential difference. So where does that difference in electrical energy come from? Well, in a DC circuit, the ones that you're going to be building using the FET circuit simulator, they come from the cell, from the battery, if you've got more than one cell. So the cell in the circuit is what provides this excess and deficiency of electrons because it's got a positive and a negative terminal. Okay. So the positive terminal would attract electrons and the negative terminal would repel electrons. If I put a cell over here, remember that's the positive one, the long thin one's positive, the short fat one's negative. Use a pencil and a ruler to draw this. If I put an electron here, if that's the negative side and this is the positive side, the electron would be repelled from the negative. And if I put an electron here, the electron would be attracted to the positive terminal of the cell. Okay, so the voltage of the cell, we also call that the potential difference. More formally is called the potential difference. The potential difference is the amount of electrical potential energy which is available. The unit for potential difference is the volt, and the symbol for the volt, you should remember from your SI units, is capital V. Okay, so please make sure you learn definitions, guys. I hope that during science this year you've been getting cue cards, and every time you get a new definition you're going to write your definition on the cue card. So here's another one. Definition for potential difference is the work done per unit positive charge. You may wonder why it's a positive charge. I told you when we started the section, we talk about conventional current, and that's what a positive test charge would do. So all our formulas are based on that, and that's why potential difference is the work done per unit positive charge. Okay, so if you've got a high potential difference, you can do a lot of work. Potential difference is the energy used between 2 points in a circuit. So it's measured with a voltmeter. And you connect a voltmeter across either side of a component. Sorry, you will have to write a bit small there. So we measure potential difference with a voltmeter, and you connect a voltmeter across either side of a component to measure the potential difference across that component. So in the pictures over here, we've got a little example. Here is a component, it's a resistor X. Now notice how there's a voltmeter. Remember the symbol for a voltmeter is a capital V inside a circle. You connect that across that component. Okay. So voltmeter is connected across a component. Voltmeter is connected in parallel, which means that some current can go from the negative terminal of the cell through the voltmeter. Very little will go through there because voltmeters have got high resistance, but most of the current will go through the resistor. So that's what most of the current does. Some, though, will go through the yellow path just a tiny little bit, and the voltmeter detects the difference in potential energy across that component. So very, 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 very little current, almost no current will actually go through the voltmeter, and the reason why is because voltmeters have got very high resistance. I'd like you to make a note of that here, please, guys. voltmeters have high resistance. Voltmeters have got high resistance, and that's to prevent much current going through it. We just want to check what the potential difference is across that resistor. So on either side of that resistor. That's why voltmeters are designed to have very, very high resistance. Okay, so make a little note here, voltmeters connected in parallel. Okay, let's talk about what's happening over here. Even though we're not really discussing current at the moment, I just want to refresh your memory. So here we've got an ammeter. Let's do it in a different color. We've got an ammeter, symbols a capital A inside a circle. Notice how the ammeter is connected in series. Okay, so ammeter is connected in series. So all of the current goes through the ammeter. And because you want all the current to go through the ammeter, ammeter must have very, very low resistance. So I'll do it in red. Here's a resistor. Let's try that again in red. You've got resistor X, so that resistor has got some resistance. If you want to measure the current going through it, you'd have an ammeter connected in series with it to measure all the current that's going through that resistor. But if you wanted to measure the potential difference of it, you'd have to connect a voltmeter across that component. So voltmeters connected in parallel, ammeters connected in series. Okay, so ammeters connected in series, ammeters got very low resistance. You don't want it to interfere with your circuit, so that's why ammeters got very low resistance, whereas voltmeters connected in parallel and it's got very high resistance. And the reason why is because you don't want much current to go through this voltmeter. You want the current to go through the main line of your circuit, through the component that you're trying to measure the potential difference of. So you want the current to follow the green line in this circuit rather than the yellow, so that you can measure the potential difference across that resistor. Alright, I'm going to explain investigation 2 to you. So investigation 1 was all about current, investigation 2 is all about potential difference. Dr. Thornton's going to do experiment or investigation 3 with you, and that one's going to be on resistance. So experiment 1, investigation 1 was current, investigation 2 is potential difference. And next week, you're going to do investigation 3, which is going to be on resistance. Okay, so we've got two circuits. We've got a series circuit and a parallel circuit. Let's talk about the series circuit first. So here's a series circuit. We've got one cell, and we've got two light bulbs. There's only one path for current to take, so that's why we say that it's a series circuit. If I asked you to show conventional current, it would be what would a positive test charge do? Positive would go that way, so that would be a conventional current. Actual current though, what would an electron do? An electron would go around that way, repelled from the negative and attracted to the positive. Okay, you can play around with that when you do your FET circuit. In the FET circuit, there isn't a voltmeter that you can connect into your circuit, but you can drag one next to your circuit and you connect it at different points. So you're going to have one cell. You're going to connect that one cell in, well, there is only one, so you can't connect it in series or parallel if there is only one. I'd like you to adjust the voltage or the potential difference of that cell so that it's 1.5 volts. And then you're going to add two light bulbs. Those you're going to connect in series. So there's your two light bulbs connected in series. Please adjust the resistance of those light bulbs to be 1 ohm each. 1,0 ohm, 1,0 ohm. So each of your light bulbs has got a resistance of 1 ohm. Each of your, or you've only got one cell, it will have a potential difference of 1.5 volts. Okay. Then you're going to have your voltmeter. Remember what the voltmeter looks like from our previous videos where I showed you how to use the FET circuit. Remember, it's got the black lead, and it's got the red lead. This is the positive side of your cell, and this is the negative side of your cell. Make sure that your black lead gets connected anywhere on the negative side of your circuit, and the red lead gets connected anywhere on the positive side of your circuit. So you need to connect a voltmeter into three different positions, sorry. The first is going to be voltmeter 1. So voltmeter 1 is over here. You will then connect the red lead on your voltmeter in the FET circuit. You're going to connect the 1 point there, and it'll then go to your voltmeter. And then the black lead, so the black lead on your voltmeter, you're going to connect to this point. Black lead on your voltmeter, you're going to connect over there. And you're going to see what the reading is in your voltmeter. Okay, so that'll give you a reading for voltmeter 1. Then you're going to write down that value over there. Alright, next what you're going to do is you're going to take your voltmeter. Let's draw in our funny little voltmeter again. There's a voltmeter. You need to determine the potential difference across the first bulb. So there's your first bulb. There's your first bulb. And you're going to connect the positive lead of the voltmeter to the positive side of your circuit, because this is your positive side of your circuit. The negative side of your voltmeter, you're going to connect that over there. And you're going to tell me what the reading is on your voltmeter, and that value you're going to write down over here. And then the last thing you're going to do with that circuit, you're going to determine what the resistance, you're going to determine what the potential difference is across this light bulb. So that'll be voltmeter 3. You're going to take the positive lead and connect it to the positive side of your light bulb. And you're going to take the negative lead and connect it to the negative side of your light bulb, and note what the voltmeter reading is for that light bulb. You're going to note that value over here. Okay. Then you're going to do something very similar for the parallel circuit. Let's just get rid of all of this. So you're going to start a new circuit. It's going to be a parallel circuit. Again, just one cell. Please select the potential difference of that one cell to be 1.5 volts. 1.5 volts. You're going to have two light bulbs. They're going to be connected in parallel. Please make sure that the resistance of each light bulb is 1 ohm, and that one's also going to be 1 ohm. Alright, so you're going to take your voltmeter. There's my weird little voltmeter. And remember, I said this was the positive side of the circuit, which I'd like to do in red. So there's a positive side. So the positive lead you're going to put over here once you built your circuit, and the negative lead you're going to connect over there, and then you're going to write down your reading for voltmeter 1 over here for your parallel circuit. Then you're going to repeat. You're going to put the positive lead in the position that I'll show you now. There we go. And the negative lead's going to go over here, and you're going to note the reading on the voltmeter for voltmeter reading 2, and you're going to write that over there. Please make sure you also put units. Your unit's always going to be volts. Volts, 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 volts. Okay, and then you're going to do the same thing for voltmeter 3. Move the leads of your voltmeter on the FET circuit simulator to be over there, and you're going to note how many volts you get over there. Then I'd like you to compare your readings. So for this series circuit, I want you to tell me what the relationship is between voltmeter 1, voltmeter 2 and 3. Are they all the same? Does 2 and 3 add up to give you 1? Does 1 and 3 add up to give you 2? And so on. And you're going to write a conclusion. Once you're done with that, then you can start with the next video.